Hello everyone, I'm going to do a few quick examples just to clarify what we spoke about today on Unit 3, Day 1 of exponential functions. Again, what we're dealing with is exponential functions, meaning that you understand that we've got a parent function of y equals an initial number times a base with the argument as of x value, meaning our independent variable is changing the exponent, not changing the base, but changing the exponent. That'll give us one of these two graphs. If your base to your power is bigger than 1, you're going to get the first graph, which is shooting up to the right quickly. You've often heard people talk about it growing exponentially. That means very fast. So that would be something like y equals 2 to the some power, or 7, or any large number, 10. Could be even the letter e, which is 2.718. But if your base changes to a decimal or a fraction, not a negative, but a decimal or a fraction, so like let's say 1/2, and we raise that base to a power of x, then what's going to happen is, because it's a reciprocal idea, whereas 2 grows, 1/2 decays. So on the right graph you see here in red, this is exponential decay. So their end behavior is opposite of each other. So keep that parent function in mind, where in both cases you understand that 0, 1 is your anchor point, your y-intercept, and that both of them have horizontal asymptotes at y equals 0. Why is that? I want you to think about that for a minute. Look at these two equations. If I took this equation and I put a negative number in here, so let's say I'm moving to the left on my axis. If I put a negative number in there, negative powers, remember, just indicate that there's a reciprocal. So 2 to the negative 1 power is 1/2. If I did the same thing over here, and that's why if you look here, again, back 1, up 1/2, it never gets negative. You don't ever go below this x-axis. If you do the other one, the decay, putting that negative power is just changing that to a reciprocal, so you get y equals 2. So on the graph number 2, if you went over 1 to the left, you would go up 2. That's why you're here. Again, nothing ever goes in the negative y zone unless there's a shift. So keep those parent functions in mind. Let's talk about some transformations in graphing. So before we get into the specifics, let's review. We're going to have to look at the equation very carefully and look at what's in front of the argument. For today's lesson, I'm going to assume a value is 1. We'll look at what's in front of the argument and say, you know what? Is there a negative there? Does that reflect? We're going to also look inside the argument and look for negative values there to see for reflection. We also might be dealing with translation, so there might be shifting directly to the right here, which would be vertical, or there might be shifting inside the power, inside the argument. All of that shifting will change us and give us a new anchor that will go from what we thought it was originally, 0, 1, and we'll do some adding and subtracting with the shifts and get a new anchor. The reflections are obviously going to change the direction of the graph, so instead of going from the first one here, which is apparent, maybe it reflects over the y because there is a negative inside the argument. Maybe it reflects over the x because there's a negative outside the argument. In other words, what I'm saying is perhaps you have, in this case, b to the negative x, and in case here, this would be the base to the x, but there would be a negative in front of your base. So we have to watch for those. Finding the y-intercept is something a lot of instructors do. It's really nice to have there. It helps with your accuracy of your graphing so that you know that your curve is going into the right, towards the right direction with a little bit more clarity. And then we're going to make sure that we pay attention to the reflection that we have. Not only the reflection, but the translations we have. And that will change that original y equals 0 horizontal asymptote into something else. So let's try some work here. All right, what we've got here is an equation with a negative sign I see that's going to be reflected and a 3 that's going to be some shifting. So let's be very, very organized with what we do for order. Remember, I've always told you to factor inside the argument and then reflect and then shift and then translate. Or excuse me, stretch or shrink. We're not going to do the stretch or shrink today. So it looks like we do have a reflection that's over the x-axis. So what happens is it used to look like this, But now we're going to change, and it's going to flip over here this way. The direction is going to change. So we've got to make sure we're paying attention when we graph to that little shape. We have, looks like a horizontal shift. So that anchor point that used to be 0, 1 is going to move, in this case, right there to the left 3. So we're going to have to take that x value and shift it left 3. There's no vertical shift, so it looks like we're going to end up at -3, -1 for our new anchor. So new direction, new anchor. Again, there's no vertical shift going on. So let's get that going right now. -3, -1, there's our anchor. Let's get the horizontal asymptote sketched out as a guidance line to not cross. And then to be more accurate, I know I'm going to hug the asymptote, and I know I'm going to cross through here, but to be a bit more accurate with my direction and where it's heading, I'm going to find the y-intercept right now simply by taking my equation, substituting in 0 for the x value, and then working that out. So that'll be -2 to the third power, which is 2 to the third is 8, and it's -8. So that's right there. Anchor again was up here, and now I can finish that sweep, that quick sweep, and there is your graph. So as you can see, as long as you pay attention to your reflections and your translations and do some moving from the original parent, it's fairly easy to predict what the graph is going to look like. As always, you could go to any graphing tool, calculator, Desmos, and double check, but you should never be starting there first. You should be able to predict before you get started. Please reach out if you have any questions.